Math. In this lesson, we are going to look at the geometric sequence. Now, in a previous lesson, we looked at an arithmetic sequence where the establishing feature was that it had a constant first difference. So I'm adding the same number the whole time. But now we're shifting over to something new. If you look at the sequence on screen, 2, 6, 18, 54, I'm not adding the same number. But if I multiply by 3 the whole time, then I get the next number. So this is called the constant ratio. And with any geometric sequence, this ratio would always be the same between two numbers. I am multiplying to get the next one. So let's look at another one. With this one, again, I'm multiplying with a specific number, but this time the number is a half. So multiply by a half, I get 50, multiply by half, I get 25. Okay, and another one. Now you would notice something strange, that the first term is negative, the second term is positive, and then negative, and then positive. So it alternates the whole time. In this case, the common ratio would be -4. Okay, so it's not that the ratio is small, it's just that the ratio is negative, and that's why the sign changes the whole time. In this case, with this sequence now, it's getting bigger each time, but it doesn't really look like a sequence. It looks like I'm just moving the 1 or moving the comma. But in actual fact, you are multiplying by 10, which also makes it a geometric sequence. I hope it makes sense, the difference between an arithmetic sequence and a geometric sequence. I'm multiplying by the same number the whole time. Okay, now some schools have been teaching geometric sequences early on, but not in depth. So this formula you see in green, you might have noticed somewhere, but in grade 12, it's the first time you're really going to go in depth and do it backwards and forwards and learn how to use it. Okay, so just like in our previous video with arithmetic sequences, A always stands for the first term, but in this case, we don't have a D, we have an R, standing for the constant ratio. So that is always the first term. That is now the constant ratio. Whoops. Okay. And if you notice here, if the ratio seems a bit tricky to just look at it and see what it is, you can always use the formula term 2 divided by term 1. Now remember, with arithmetic it was minusing, but with geometric I am taking a number on the right divided by the one just left of it. Okay, that's how you're going to get your R. N is still the position, and Tn is still the value of the term. So there's many similarities between arithmetic and geometric. The biggest difference is just the ratio instead of the common difference. Okay, so if I'm asked to get the general formula for this specific term, I would just say Tn is equal to the first term. Now, it's very important that you use brackets with this one. Okay, I don't know what R is, so let's use this formula to see what R would be. I'm going to take term 2 divided by term 1. And 6 divided by 2 is going to give me 3. But there's a minus, so this is -3 as my constant ratio, and then n minus 1. And that's it, I'm done. So there's less working out than in an arithmetic sequence, actually. Okay, so that is how you use the formula for a geometric pattern. And then from here, if they ask me what's the 10th term, I can sub it into n. If they ask me what is the position of a term with a specific value, I sub it into Tn. Okay, let's look at this example, which you could find in a test or in an exam. Okay, for question 1, find the nth term. Now, if I first look closely at the sequence, a half minus an eighth, and then 1 over 32. Okay, so I can clearly see I'm not adding a certain number to get to the next one. And therefore, I'm going to test, is it maybe a geometric sequence? Now, remember, we said to get the common ratio, I can say term 2 divided by term 1. Okay, in this case, this is giving me a negative a quarter. Okay. Now, to test if something is geometric, I just do this formula again. So I'm going to take term 3, 1 over 32, divided by minus 1 over 8. And in this case, if I type it in my calculator, I still get minus a quarter. So now I know for sure this is a geometric pattern. Okay, find the nth term. So let's just do it up there. Okay. Formula that we did earlier was Tn is equal to A times R to the power n minus 1. My first term in this case is a half. R that we found in this calculation up top was negative 1 over 4. And the other values I am just keeping as variables because they haven't asked me for a specific position or value. Question 2. what is the value of the 10th term? Now I'm going to use my Tn formula. Now guys, please do not multiply the half and the quarter. In geometric sequences, and remember our grade 9 exponent rules, if the exponents are not the same, you're not allowed to multiply the bases. So I'm just keeping my Tn formula like that. To get the 10th term now for question 2, I'm going to take my formula and I'm just going to sub in the value of 10. So T10 would equal to a half times negative a quarter to the power 10 minus 1. Okay, type that on your calculator and you would, and always leave this answer as a fraction. Don't go decimals because then you have to worry about rounding off. Okay, 524,288. Your answer might look strange, but get used to it. Grade 12, the answers are going to not all be nice and rounded off like you used to in previous grades. Okay, let's look at question 3. Which term in the sequence is equal to that number? Now they're giving me the value and asking me the position, so I'm straight away going to sub in this big fraction. 32768 equals to a half, negative a quarter, and n minus 1. First thing I want to do is I want to get rid of that extra half that's there. Now remember, I'm not allowed to multiply the quarter with the half, so I'm going to multiply both sides by 2 to get rid of it. That now brings me to this number, which is slightly easier to read, but it's still a massive fraction. Okay, now depending on when you watch this video, there's 2 different methods to go from here. I'm going to assume you're watching this video at the beginning of the year because this is chapter 1. So we're going to use prime factorization to solve this question. But after you've done chapter 2 in the book, which is functions and inverses, you would use the log method. In later videos, I will explain geometric patterns with logs. But for now, let's stick to prime factorization. What that means is on your calculator, you are going to use the shift fact function. It can't take a fraction, so please type in 16384 equals shift fact. And that's going to tell you this is 2 to the power 14. Okay, now we know it was a fraction, so please just write your answer as a fraction as well. Now my problem is the right side is a quarter, it's not a half. But I know a half squared is a quarter, so I can write this as minus a half to the power 2 n minus 1. Now I'm sitting with another issue. I want the bases to be the same. So that minus is now a problem. So we can't just take away the minus. But because the exponent on the left is an even number, the even number would cancel a minus. So I can assume that it was actually a minus all along. The even number just cancelled the minus. Okay. Now when I get to this point, grade 9 exponents, the bases are the same and therefore they can drop and you can say 14 is equal to 2n minus 2. Therefore n is equal to 16 over 2. And therefore, which term is equal to that number? The 8th term is equal to that number. I hope this makes sense and you can see the difference between arithmetic and geometric. This was how to use the Tn formula for both. After this lesson, we're going to look at the Sn formulas for both of them.
If this video helped you, please like and subscribe.
JJ Math.